Hi everyone, I'm Kaz. I and Rakesh will present you a session. And actually, we have changed the session title on the slide. Now it's called From Siloed ML to ML Service Mesh with API Management. And I'm Kaz, a developer advocate from Google Cloud. And Rakesh? Rakesh.
Hey guys, I'm a principal architect with Apigee API Management. I work with customers. Thank you.
Thank you. So for these sessions, I will talk the first part, and then I will pass the screen to Rakesh, and he will take the second part. Okay, this is the agenda. So at first, I will talk about how you can build a scalable machine learning development environment and deployment environment by using the Google Cloud AI platform. And I will discuss about the challenges we have. It's a siloed ML, we call it, and how you can build an ML service mesh to solve these problems. So how you can build a scalable production-ready machine learning development and deployment infrastructure with the AI platform. So as you know, we have many different roles to build a single machine learning production systems. Starting from the data engineers, or researchers, data scientists, or ML engineers, or ML ops person, or usual developers, and also the business people have to join the team. So that is how you can build the scalable ML teams in production. And each role should be responsible for different phases in the ML lifecycle. For example, data engineer can focus on ingesting the training data from data warehouses, and also apply the pre-processing at scale, whereas the data scientist can focusing on the designing a model and getting the best accuracy from that. And then the ops engineer can take the responsibility on delivering the machine learning model for the prediction infrastructure. And also the ops engineer have to be responsible for the so-called ML ops issues, such as the continuous training, continuous delivery, and continuous monitoring of the performance of the ML model. So for example, in this scenario, data scientist is visiting a cubicle of the ops team for asking for how he can bring his POC notebook model into a production services. But there's a big gap between the POC notebook and the production system. For example, the POC is dependent on the one single person, whereas the production services should be portable and shareable. And you cannot handle the 1 million or 10 million users with a single notebook instance. So you have to set up all the auto scaling and load balanced the production serving system. And you cannot dependent on the fragile manual process. Instead, you have to build a reproducible and end-to-end life cycle that anyone can invoke the whole pipeline. And also you have to think about continuous monitoring as well to keep watching how you are making the value to the business KPIs. So this is the reason we have launched a product called Cloud AI Platform Training and Prediction. So these are the managed services for ML training and prediction. So instead of having you creating instances for virtual machines or the are we having a trouble on audio? No problem. Okay. Yeah, I'm getting a chat. So the auto scaling prediction means you don't have to take care of the life cycle of the instances or the contents by yourself. So the scaling out and scaling in is taken care by the machine learning prediction setup. So it reduces the workload for the ML ops engineers. And by using the AI platform, you can solve the many the problems for the production systems, like scheduling of the containers or the instances, scheduling of the lifecycle management and scaling out, scaling in, or the balancing, logging and monitoring, troubleshooting, and so on. So instead of implementing these features by yourself from scratch, you can let Google take care of these problems for your machine learning systems. So now I'd like to cut into the real problem, that is a siloed ML problem. So as we discussed, the ML ops teams can build this kind of the scalable and robust production system by using container-based serving infrastructure, maybe for a recommendation service, so that you would take many recommendation requests from your web front end or maybe from the other services in enterprises with the load balancer, and the load balancer will dispatch those requests into the multiple containers so that everything is scalable and available. But the problem is that, do you do that for all the different projects, machine learning projects and AI projects, such as the ads optimization project or fraud detection, demand forecasting, customer support, research, and everything? If you're a data scientist or ML ops team in a single enterprise, you would have like 10 or 20 or 30 different machine learning projects running in parallel. And do you want to build a siloed ML pipelines for those multiple services? So this is maybe anti-patterns we will be seeing for many cases in coming years, siloed ML pipelines. So each project is reinventing, building the prediction capabilities from scratch. For example, some predicting the user profile from user activities, or predicting a product profile from its description, and so on. So the solution could be building an ML service mesh. You can get started with build a single monolithic application in the initial phase. But after that, you have to split the prediction capabilities as modules. And in the end, you would see the mesh of the microservices for the individual prediction capabilities, so that you can share the prediction capabilities across the enterprise with the multiple services. And another the idea we want to bring is the embeddings. So building the ML service mesh with the embeddings, so that we can share we can use the embeddings as a lingua franca for representing entity profiles across different projects, teams, and organizations. For example, as you can see on this diagram, the service A can predict the user embeddings, and another service can predict the product embeddings, so that the service C can take those two embeddings, combining the same, and provide the recommendation for the products. And what is embeddings? So in the past, most of the IT systems is relying on the labels or tags attached to this certain data. For example, if you have millions of images, you would have a cat, dog labels on those images. But what if you can represent the characteristic of each image as with the bunch of the numbers called vector? So some people would say it's a feature vector, or embeddings. Embeddings means there's some intelligence extracted by the deep learning models. So for the word embeddings, you can define the distance or similarity between each words. The word music closer to the word songs, or the image similarities. Maybe the cat images will be similar to the dog images and far from the car images. So this is a demonstration how you can use the embeddings on the BigQuery, which is a data warehouse of Google Cloud. So it is running a image similarity search by using embeddings, by calculating the distance between the embeddings vectors within the data warehouse. And you can do it by using the BigQuery ML features inside it. So instead of finding the fish or maybe dotted fish as the tagged images, instead this feature is actually comparing the similarities between those image patterns, colors, or shapes, and finding the similar images. So this is the idea, but what is the missing link? We think the missing link is the API management. How to build a service mesh for the sharing embeddings. You have to make sure that you are sharing the assets with a proper business model and security model. And API management could solve these problems. So I'd like to pass the screen to Rakesh to explain that.
All right. So we have embeddings. So most of the times, ML engineers build embeddings. The problem is in the adoption. How do you make this easy to consume, right? And then one way to do that is to expose it so that it can be easily consumed. What I'm going to talk today is about service mesh architecture, how to enable this. Most of the companies are going through this journey of breaking the monoliths into microservices. So in this journey, some people have already, probably they've started with service-oriented architecture, probably they're halfway through. Now, what's the idea between microservices? Why do you need this pattern, right? So basically, microservices are a set of loosely coupled services that can interact with each other. What's advantage? Advantage is to increase the product velocity, meaning you can release more often into production, right? You want to manage the complexity of the code so that you can make those releases faster, right? You want to admit there's heterogeneity. Some developers like one language or the other languages, so you want to allow that, right? And then you want to empower the developers. So microservices is a pattern that is widely getting adopted. Now, once the microservices will come into picture, what is the contract between the services, right? It's the APIs, right? APIs will give you the contract to consume those services. And once teams start to build the services, you'll get into a mesh of these services. Once you have the mesh of the services, people can use different data formats, GraphQL, JSON, YAML, or they can use different protocols for communication, right? They can use gRPC, HTTP, right? Or they can use something else. So what is, let's double click and go down a little bit. So how do you build a service mesh? And how do you make the embeddings also part of the service mesh so that the applications can be consumed, right? Let's talk a little bit about basics of a service mesh. So you have service A and service B, right? Now they can communicate over the protocol, HTTP, gRPC, TCP, right? Now you want to secure them. The most common way between the most desired way, I would say, is mutual TLS. Once you have mutual TLS, you want to manage those certificates, right? Ideally, you want to give one certificate per service. In that way, when they do a handshake, it's unique. But we know in some places, the certificates are shared and it's cheated, right? Let's assume everything is done right. Once that is done, you want to centrally manage the endpoints for authentication, authorization, and even things like retries, right? Timeouts. These are something not ML engineers or application developers are concerned about. But from a technology standpoint, for a high throughput system, you still have to worry about that, right? Even at runtime, some of the services may not be available, right? They can be start, stop, releases going on. So there are challenges. Once you have the services, you want to collect the telemetry. You want to know the performance of the systems. You want to know if the service is available or not, right? And what to do once if it's not available. So we need some kind of a support system to support all of this so that our engineers or ML engineers are not bothered with any of these things. This is where a pattern like Envoy comes into picture. So Envoy is a high throughput. This is the Envoy. So Envoy is a high performance pluggable proxy, right? All the heavy lifting is done by the proxy, which is built on the learnings of HA proxy in Nginx. And even Apigee developers, we have fans of them. And what we have done is to try to take advantages of Envoy proxy and bring in the API management. So the sidecar pattern of the Envoy is what makes this happen. Instead of embedding all the libraries that is required to handle this into the application, what we're doing is the Envoy gives things like, how to easily support services implemented in multiple languages, how to introduce circuit breaker, timeouts, retries. These things will just come in. And this is where a good control plane helps. To manage these things across a big service mesh is where the control plane comes in. Now, me as an ML engineer, I'm thinking, is it getting too complicated? Is it out of my realm, right? So that is a challenge that I have to face now. Now, in order to reduce that, right, we started the problem of taking a monolith and breaking down into services, right? But in the end, you want a service mesh that can help you to simplify your connection, right? You want to control the flow of traffic between the services without your ML engineers doing it or other engineers doing it, right? You want to secure the endpoints, make sure only the authorized people come in and use the services, right? You want to control that by a central governing policies, right? You want governance, and you want to collect metrics as things are happening. Now comes the Istio. Istio is the control plane, right, where you can introduce the Envoy and the manageability of it. So Istio starts with the Envoy proxy as a sidecar and adds a set of policies to manage and provision the distributed sets of policies. We'll talk a little bit more of that. Now, where does API management fit in, right? Let's talk through this. So API management, let's take a simple scenario, right? You have your legacy apps, you have your monoliths, right? And then you have your consumers. The consumers these days can be anyone, right? Like assistants, IoTs, mobile devices, web applications, right? Third-party apps that you don't know can be consuming, right? So in order to manage your APIs, you have the API gateway. What is an API? Basically, we talked about it. It's a contract that you're having between your consumers and your system of records, and API gateways will enable those contracts, will enforce those contracts, right, to consume the applications outside your network. Right, let's start building on this use case. Now, as you go through this journey of breaking down a monolith to microservices, you have internal applications also consuming the same services as the external applications. Internal applications initially may not use the API management. They can go directly across the applications and call the API straight. But in case of external applications, they come to the API gateway where the contract is enabled. As we build on this, the monolith is broken down into smaller microservices, right? So the internal apps now consume both from the monolith as well as the internal services, right? And as this keeps going, we allow the pattern, what's going on. So we build new capabilities in the microservices, not in the monolith, in the microservices, and also introduce your prediction services using Cloud AI platform, where the internal apps are consuming your prediction models as well as consuming the new capabilities. Now, the same thing is also available for your end consumers outside your network, and the contracts are managed using the API platform, right? So you can see the pattern is evolving. We are getting into mesh of services here in the journey. Now let's double click a little bit and see how to do this, right? Let's take two services, right? Where you have Istio service mesh. This is where the Istio service mesh is a pluggable component where that can come in to manage your mesh, right? So you have, you can deploy it in the Envoy in a Kubernetes container, and then you can introduce what we call it as an Apigee adapter. We'll get into that a little bit. So the Apigee adapter basically will help you to enforce your policies. Let's say, for example, OAuth is the way to go about, right? OAuth is a way that your organization has said is to authenticate your endpoint. Then you can enforce as a governing policy across, right? These adapters will also help to enforce additional things like quotas, rate limiting, right? Any threat protection, things like that, you can put in the adapter. And the added benefit of all of this is it will conduct analytics and push it to your managed plane. And in the managed plane, you can look at your reports, do all kinds of things. Now, at a high level, we are building a clean separation of concerns so that we have a role for each of this. There's a service mesh like Istio. There's an Apigee adapter for enabling the management of the APIs. And then you have your applications and you have your prediction models. Everything is getting some structure here. Now, how does the Apigee adapter work? So this is a brand new offering from Apigee. It's actually a beta today, as on today. So how does it work? So the consumer calls the API, the proxy, and then the proxy in turn has filters. So Apigee remote service basically has plugged into one of the filters, right? It's an external auth filter, wherein it comes back with a response like, yes, the authentication authorization worked. Nope, it didn't work. If it didn't work, then the API call is rejected back with an error. If it works, it's sent to service A. Right. So in order to enable a high throughput system, right, the Apigee remote service communicates with the proxy on gRPC, right, HTTP2, right, and also it caches all the policies from the manager plane and keeps it in the remote service. And this is how you can build a high throughput system. Okay, so why use API management in your service mesh? I'm trying to bring all of this together, right? So you have your prediction models, and now we want to see how to make the adoption easy. So an API management layer will help you to enable that. How? So basically, an API management layer like Apigee will help you to discover your service. Once you build your service, we want it to be used. So a good, nice portal will help you to discover the service. It will help you to modernize your applications, whether it is your legacy applications or monoliths. It will help you to modernize, have a nice HTTP REST layer on top of your legacy applications. It will help you to do self-service. There's no more site conversations, your cafeteria conversations. It will enable, you come to a portal, ask for a key, you get the key, self-service provisioned, and you can start using the APIs. In the process, you have the documentation. What do you need to invoke this service, right? So you have the documentation right there. You can get reports, very important. You want to know who are my top 5 consumers for today compared to, let's say, 5 days back. You want to see what's my growth in my traffic compared to 3 months back. Or you want to see what are the errors that's happening, who is creating errors in my system, right? So those things are easily available. You can introduce governance, common policies that you can fire to all your proxies and say OAuth is my standard, and you'll get that. You want to monitor your APIs. You want to act before your consumers call you and say the system is down. You can do that through notifications. And then once you have all of the services built in, right, you want to monetize, you want to make money out of your program. You can easily allow someone to come in, swipe the card, and consume your services. There are many models to monetize. Apigee does support many monetization modules, and you can try that out. So the takeaway is you have embeddings. How do you enable adoption for easy management? The simplest and easiest way you can do is to take your embeddings, use the Apigee SaaS gateway, where you don't have to provision anything. And then you can expose your models to the Apigee gateway. It's less than a day's project if you follow the instructions. You can enable all of your models, your prediction services, through the Apigee gateway and allow your consumers to consume it. The whole thing is documented as a solution. I'll share the links to you. You can try it out. You can I'll share the solution. You can try it out, get an account, free account in Apigee. You can get a free account in Cloud AI platform, and then tie both of them together and go there. Once you have that, then you can build your service mesh behind the scenes to enable internal consumption. So I'm Rakesh, I'm principal architect with Apigee API Management, and we have Kaz. Kaz is a developer advocate in the MLAI team. If you have any questions, please do send us at our Twitter accounts. We'll be happy to respond. But let us see what questions we have here.
Yeah, we have one question here.
Okay, let me see that. Okay, so I see from Shobha, how is the service mesh architecture for AI applications any different from any other distributed software?
Yeah, can I take that?
Sure.
Yeah, I think the difference is this is a quite new practice we can introduce to the ML infrastructure. Because usually the data scientists would not think about splitting the monolithic model into the multiple models and make it shareable. Usually, if you think about, for example, building a recommendation systems, you would design a single monolithic machine learning model and do everything from scratch and for the production. But instead, we have to think about building a service mesh for the machine learning. So that changes the way the data scientists design the models. Instead of having a monolithic model or monolithic machine learning service, you have to think about how you can reuse the embeddings. For example, not just having a big model only for the recommendations, but you can split the model into a model for extracting the embeddings, or a model user embeddings, and another model for extracting the product embeddings, so that you could have the third model that takes the two embeddings as input and predict the third embeddings, recommendation embeddings, or maybe the recommendation the output. So I think the underlying technology for building infrastructure like API management or the EC2 service mesh doesn't change much. But I think this is a new practice we can bring into the world of the machine learning production system.
All right. Thank you, Kaz. All right. We don't have any other questions. I'll share a couple of links. If you want to try the solution out, let me do this quickly. All right. Thank you all for joining this session. Yeah, I just shared the link here. Thank you for joining this session. Please do comment on our session if you have any further questions. Thank you.
Thank you so much.